Welcome to the deep dive. Today, we're tackling a mission that's absolutely perfect for you, the RHCSA candidate.
Or really, for anyone who needs to solve a real-world IT problem without just throwing money at a proprietary cloud subscription.
Exactly. Our mission today is to act as consultants for a small business owner named Juanita. She runs a computer repair shop in Atlanta out in the Buckhead area.
And she has a very common but critical need. She has to manage customer records, names, phone numbers, repair histories, and she has two big requirements that are non-negotiable.
Let me guess. Data sovereignty and disaster recovery.
You got it. Total data sovereignty, meaning the data lives only on her hardware, and rock-solid disaster recovery.
Which means she needs that data in more than one place. And that's where the complexity comes in, right?
Yeah.
She's got 3 different Genia Linux machines in 2 completely separate geographic locations.
Right. This isn't a simple setup. First, there's server A, that's her back office workhorse, and it's running pop.os 24.04.
Okay, a Debian Ubuntu base.
Then you have desktop A at the front desk. This is the cashier station, and it's running Fedora 43.
And there's our heterogeneous environment, so now we have a Red Hat base in the mix.
Exactly. And finally, server B. This is the offsite backup miles away at her home, also running pop.os.
So the challenge is to securely connect pop.os to Fedora and then synchronize a critical database between her office and her home. And we're doing it all with open source tools.
Yes. Our blueprint for her has 3 layers. At the top, the application layer is LibreOffice Base.
Okay.
The network layer, the glue holding it all together, is Tailscale. And the synchronization layer, the thing that makes disaster recovery possible, is Syncthing.
And for you, the person studying for the RHCSA, this is it's a perfect project. You're forced to manage different environments. You're juggling apt and DNF, and maybe most importantly, you're configuring user space services with Systemed.
It's one thing to do it in a lab. This is a real production context. It's practical proof of skill.
All right, so let's start with what seems like the hardest part, connecting the office and home networks. I mean, traditionally, this would be a complete nightmare.
Oh, absolutely. You'd be talking firewall rules, static IPs, port forwarding. It's brittle and complex.
And this is the problem that Tailscale it just makes it disappear.
It really does. Tailscale creates a secure mesh network. It's built on WireGuard, and it basically abstracts away all of that complexity. It doesn't care about firewalls. It doesn't care about network address translation or NAT.
And crucially, it doesn't care about carrier-grade NAT.
Yes, CGNAT. That's the big one that trips people up.
Okay, hold on. Let's pause on that for a second. CGNAT. For our listeners who aren't, network engineers, what is that and why does it break everything?
It's an excellent question. So think of regular NAT. Your home router takes one public IP address from your ISP and shares it with all the devices in your house.
Right, my laptop, my phone, the smart TV.
Exactly. Well, CGNAT is the ISP doing their exact same thing, but on a massive scale. They take one public IP address and share it across hundreds of customers in a neighborhood.
Ah, so you don't even have your own real public IP address at home.
You don't, and that means you can't do things like port forwarding. So any incoming connection, like someone trying to connect to a traditional VPN server you're running at home, it never arrives. The ISP's network doesn't know where to send it.
And Tailscale gets around this.
It gets around this. It uses clever techniques. One is called UDP hole punching to establish a direct encrypted WireGuard tunnel between the office and home servers. It just punches right through the firewalls in the CGNet.
So it effectively puts server A in the office and server B at her home on the same logical private network, her tailnet.
That's the term, yeah. Every device on her tailnet gets its own stable private IP address in the 100.x.yz range, and that address follows it everywhere.
So for the RHCSA candidate, the installation here is a really good test. On the pop.os machines, what's the process?
On POP, she can use the official convenience script. It's just a one-liner with curl that you pipe to shush. It adds the apt repository and installs the package. It's quick.
But on the Fedora machine, you can't do that.
Right, and you shouldn't. On Fedora, you need to show your skills. You manually add the official Tailscale DNF repository, check the GPG key, and then you run sudo DNF install Tailscale. It shows you understand repository management.
Which is a fundamental skill. And then no matter how you installed it, the service has to run automatically.
Of course. So on all machines, it's sudo systemthiller enable now Tailscaled. That ensures the daemon starts on boot and keeps that secure connection alive.
And once that's done, she runs sudo tailscale up, gets a link, authenticates in her browser, and boom, all 3 machines are connected.
And she can verify it immediately. Just ping the 100.xyz address of one of the other machines.
And Tailscale status to see the list of peers. Okay. The pipe is built. It's secure.
Now for the cargo, the data that's going to flow through that pipe. And for that, we turn to LibreOffice Base,
which is the database component of the LibreOffice suite, the RDBMS, the Relational Database Management System.
Right. It's free, it's open source, it's available on pretty much every GNU Linux distribution out there. It's a perfect choice.
Now, Juanita makes a really important architectural decision here. She uses the embedded Firebird engine. Why is that specific choice so key?
Because the embedded engine stores everything, the tables, the forms, the reports, all the actual customer data inside one single file, an .odb file.
A self-contained package.
Exactly. And a single file is something that is very, very easy to synchronize.
And I think we should emphasize why this is so much better than just using, say, a spreadsheet in LibreOffice Calc.
Oh, it's night and day. A spreadsheet gives you zero data integrity. With Base, Juanita can define a primary key, like a unique customer ID. She can build relationships, linking one customer to multiple repair jobs over time. The data stays clean and consistent.
You don't have to worry about someone accidentally misspelling a customer's name on a new row and creating a duplicate record.
Precisely. The RDBMS enforces that structure.
Okay, but I feel like I have to challenge this. Just for a second.
Go for it.
We're talking about, business-critical records. A single-file database.
Isn't that kind of risky? Like, what about file locking or concurrent access?
That is the exact right question to ask.
I mean, what happens if the cashier at the front desk is adding a new customer and at the exact same moment the server in the back tries to sync the file? Don't you risk, catastrophic corruption?
You've put your finger on the Achilles heel of any file-based database versus a true client-server one like MariaDB or PostgreSQL. You are absolutely right that this is a risk.
So I do it.
Because we have to consider the specific scenario. This is a small business with a very sequential workflow. The data access isn't highly concurrent. It's not like you have dozens of people writing to the database every second.
It's one cashier entering data intermittently. Exactly. And the benefit of having a single, easily syncable file far outweighs the risk of a locking conflict in her specific use case. If we use something like MariaDB, we'd have to set up database replication, which is, that's a whole other level of complexity.
More complex. Okay, that makes sense. We're making a trade-off. We're prioritizing simplicity and robust synchronization over high concurrency, which Juanita just doesn't need.
Precisely. And getting Base installed is another little test for our RHCSA candidate.
Right, because it's not always installed by default, even if you have LibreOffice Writer and Calc.
It's often a separate package. So on pop.os, it's sudo apt install LibreOffice Base. Then on the Fedora machine, she has to switch gears mentally and use sudo dnf install LibreOffice Base. It shows that flexibility.
So the cashier creates the master file, we'll call it repairbusiness.odb on that front desk machine, sets up the tables, and then does a quick ls-l to check that the user Juanita actually owns the file and can write to it.
And now we have our valuable asset, that single .odb file.
So we have the secure network from Tailscale. We have the valuable cargo in the .id file. Now we need the delivery truck.
The continuous delivery mechanism, and that is Syncthing.
This is the piece that delivers on the data sovereignty promise. It is pure peer-to-peer. No third-party cloud server is involved. The data only ever moves between Juanita's own machines.
And the technology behind it is really clever. It uses something called the Block Exchange Protocol, or BEP.
Okay, what does that do for us?
It's a game changer for efficiency. See, a lot of simple sync tools, if you change one byte in a file, they re-upload the entire file.
Which for a database file that could be megabytes or even gigabytes would be awful.
It would be a total waste of bandwidth. BEP is smarter. It breaks the file down into small, manageable blocks. And when a change happens, it only syncs the specific blocks that were actually modified.
So if she just updates one customer's phone number inside that big .id file, Syncthing only sends a tiny bit of data across the network.
A tiny bit of data. It is incredibly fast and efficient, which is perfect for syncing between an office and a home with residential internet.
Now, for the RHCSA trainee, the install is pretty standard apt or DNF. But the service management is the really critical skill here, isn't it?
It is the most important part of this step. You do not run Syncthing as root. This is a user space daemon.
What does that mean in practice?
It means you have to enable the service for a specific user. The command is systemtalial enable now syncthing at juanita.service. That at Juanita part is everything.
And that tells system to launch the Syncthing process under the Juanita's user account.
Yes, so it inherits all of her file permissions correctly. It can read and write the database file in her home directory without any issues. It's the principle of least privilege in action.
Perfect. So once those user-level daemons are running on all three machines, she configures it through the web interface on port 8384.
Correct. The first step is to exchange the device IDs between the three nodes. These are basically long cryptographic keys that let them identify and trust each other.
And this is where all layers come together so beautifully. When she tells Syncthing how to connect to the other machines, she doesn't use some flaky public IP address.
No, she specifically tells it to use the stable private 100.xyz addresses provided by Tailscale.
So all that peer-to-peer block-level synchronization traffic, it's not going over the raw public internet.
Never. It's fully encapsulated and encrypted inside the WireGuard tunnel that Tailscale already built for us.
Right.
It's security layered on top of security.
It's beautiful. So she sets up the folder share, points it at the directory with her repairbusiness.eb file, and shares it from desktop A to the two servers.
And within moments, thanks to BEP, that file is replicated. She now has 2 live synchronized backups and a front-end workstation, all using the exact same data.
I mean, what she's built here is incredible. It's a professional-grade, resilient, decentralized system, LibreOffice Base for the data structure, Tailscale for the secure network, Syncthing for the sovereign replication.
And not a single monthly subscription fee to a proprietary cloud vendor. She owns everything.
And for you, the learner, the skills on display are a perfect map of what the RHCSA tests. You've managed user context services and systemed. You've handled software on different distribution families. You've built a secure network across the internet. And you've made intelligent architectural trade-offs.
It's basically taking cloud-native thinking and applying it to your own on-premise hardware, which leads to a final provocative thought for you to consider.
Sarah.
So we know Server B is miles away in a totally different part of Atlanta, that geographic redundancy is critical. How does this decentralized block-level sync model fundamentally change her recovery time objective, her RTO, compared to a traditional solution like, say, taking a tape backup home every night? And what does that mean for how every small business should be thinking about the power of the hardware they already own?